variation functions, section 8.1, algebra 2. We are starting chapter 8 today. We're going to talk about some different types of functions without the chapter. Today we're going to talk about direct and inverse variation. Yes, sir.
Is this a long chapter?
Kind of. All right, vocab here. There's two of them. Direct variation. Direct variation is a linear function defined by an equation of the form y equals kx. Okay. Where k cannot equal 0. Now, y equals kx, what that would look like is something as, say, y equals 2x. Now, when you look at that, what's that very similar to? An equation of a line. Hey, look, linear function. We're talking about line functions here. That's what that is. If I look at this function, what does k represent? K equals what in this function right there? Y equals 2x. K would equal? 2. That's my constant of 2. Okay, identifying that is important today. K would be the constant 2. The constant of variation. When x and y are variables, you can write k equals y over x. Okay, k equals y over x. So the ratio y to x equals the constant k. I just made that up. Arbitrary number. I could have made it 3 if I wanted to. It's just arbitrary number. Now, where does k equals yx come from? It comes from this equation y equals kx. Alright? If I take y equals kx, and I said solve for k, as in get k alone, you would then divide both sides by x, getting you k equals y over x. That's really what we're going to be focusing on today. Alright? So the constant of variation is k equals y over x. Y over x is the constant of variation. Okay?
I hate these things. Look at this.
Yes, sir. They practice. Direct variation. First thing we're going to talk about is direct variation. The variable y varies directly as the variable x if y equals kx for some constant k. Varies directly means proportional. Okay? Varies directly means proportional. So for instance, y equals kx. Use the known values y and x and solve the problem for k. If it's proportional, that means y over x is going to be the same as y over x. Okay? You can use a proportion to solve these. Now, they go through using the equations. Using the equations is actually more steps and more work. Proportions is a lot easier. For instance, use 52 or use y equals 52 when x equals 4. Y over x says 52 over 4 equals solve for y when x is 6. Well, 52 over 4 equals y over 6. And then I can use cross products and solve for y. So 52 over 4 equals y over 6. I can use cross products and solve, and I get y to come out and be 78, which is the same answer. Now, that's actually the same problem that was on your warm-up. Okay, and you already solved that using proportions. Using proportions is, again, the same idea. So y equals 52 and x equals 4. Find y when x equals 6. Just set up a proportion would be a lot easier. Okay. It talks about two different points, man. That'd be like if I give you the equation like y equals 2x. Okay? If I said x equals 1, what's y? 2, right? Let's say x is now 2. What's y? 4. See? X is 2 values. It's all about the ordered pairs with them. They're just like ordered pairs, Lane. Okay. Yes, sir.
Is this what we did? Like, this is like what we did in geometry?
Very similar in a sense.
What we did today?
Kind of. Joint variation. The variable y varies jointly as the variables x and z. Now what this means is I have now y equals kxz. Or really, varies jointly means y over xz equals y over xz. Okay, the only difference between varying directly and varying jointly is the x is the z. And the z goes the same as the x. Okay. So once you solve it all the same. Y equals 90, x equals 36, z equals 5. You would say 90 over 36 times 5 equals, find y when x equals 40, z equals 3. Y over 40 times 3. And then I can still use cross products and solve. Okay? But again, it's just using proportions to solve these different values. Okay. So let's look at number 1 here. If y varies directly as x, so again, varies directly means y over x, and y equals 30 when x equals 20, so 30 over 20 equals, find y when x equals 50, y over 50. And then I can use what process to solve these? Cross products. 30 times 50 is 1500. 20 times y is 20y. Divide both sides by 20. And I get y comes out to be 75. That's all it's asking. Proportions. Yes. In a sense, just kind of wordy problems. Next one says y varies jointly. Jointly now means y over xz. So y equals 150. When x equals 2.5 and z equals 12, I would say 150 equals 2.5 times 12, which equals, find y when x equals 4 and z equals 6.5. Y over 4 times 6.5. And then I'd solve the fraction from there. 2.5 times 12 is 30. So we really get 150 over 30 equals y over 4 times 6.5 is 26. So now I would use cross products, or you could simplify the fraction and then use cross products. Multiple ways to do these, right? But I use cross products here. I think I get 30y equals at 3,900. Is that right? Yes, it is. Huh? It is. Divide by 30. And I get y to come out and be 130. Which, if you think about it, that word makes sense. 150 over 30 is 130 over 26. That does make sense. Okay, and again, the biggest thing here is set up proportions to work these. Try these 3. Suppose y varies directly with x, and x equals 27, y equals negative 51. Find x when y equals negative 17. 4, if y equals 4 when x equals 3, find y when x equals 6. And 5, if y equals 7 when x equals 2, find y when x equals 8. Take a couple seconds to try these 3. Number 3. What's the proportion you would set up, Lane?
47 over negative 51. Then x over negative 17.
Y over x equals y over x. Did you put y over x?
I did actually,
Yeah, not the same. I mean, you got the same answer, but that's not direct variation. Y over x. There is a difference.
You must have get it right, isn't it?
Huh?
You must have
You get the right answer, but you do not have the right constant. Yes.
I still get the right answer.
It would have to be negative 51 over 27 equals negative 17 over x, because it's negative. And then I get x equals what, Lane? 9. Now, you come up with the same letter, but you would not have the right constant. If I were to ask for the constant, it would be. Because your constant would be the reciprocal of what it is. Okay. Number 4. If y equals 4 and x equals 3, find y when x equals 6. Kelly, what'd you get? Y equals 8. Number 5. If y equals 7 when x equals 2, find y when x equals 8. Jersey? Number 5. Thanks, Jesse. Because you'd say 7 over 2 equals y over 8. What did you say, Jesse? I agree. Y equals 20. See? Look at that.
First one I did, but
All right, next thing we're going to talk about is if it varies inversely now. The variable y varies inversely as the variable x if y equals k over x. Notice the difference. Okay, inverse variation is y equals k over x. Direct variation is y equals kx. Okay, so notice the difference here. Now, a couple things here. If I were to take this function right here, y equals k over x, and I asked you to solve for k, what would that be if you were to solve for k?
Can you get Nolan a pencil, please?
I'm out, sorry. What would k equal here? K equals what? Anybody?
Let go of my wrist, yeah.
K equals yx, right, Jesse? So to solve for inverse variation, you would say yx equals yx. That is inverse variation. Direct variation is y over x. Inverse variation is yx equals yx. Notice the difference here. So for instance, if y varies inversely as x, y equals 4 and x equals 30, I would say 4 times 30 equals, find y when x is 20, equals y times 20. 4 times 30 is 120. Y times 20 is 20y. Divide both sides by 20 and I get y equals, what is it? Y equals 6. And recognize that is the same answer right there then. Okay? Again, you can use the equations. You don't have to use the equations. Okay? And again, when you multiply them, that is how you get your constant. So 4 times 30, 120. That is my constant. Recognize that. All right? So inverse variation. To graph the inverse variation function, we can graph these. Y equals 120 over x. Make a table of values. No. Ooh. Gotta go back one here. See these x values? Where do you think those x values come from? You pick them. Okay, you pick those x values. You can pick any x values you want. Now, as I look at this graph right here, or as I look at my function, what value can x not be? X cannot be what value? 0. X cannot be 0. Okay, why can x not be 0? Because 0 cannot be in the denominator. We all understand that, right? 0 cannot be in the denominator. All right? So what happens here is when I have that, is I get what is called an asymptote. Guys, I get what's called an asymptote right here. All right? This asymptote shows that this graph is going to get as close as it can to that line. It will never actually cross that line or touch that line. And that is the true on both sides. What did you say? Asymptote. We're going to talk about a lot about asymptotes in the future sections here. All right? And that comes down from you cannot have 0 in the denominator. If you understand that, that will help out a lot in the coming sections. Okay. So let's go through number 6. If y varies inversely as x and y equals 2 when x equals 9. So remember, inverse variation is y equals k over x, or yx equals yx. So y equals 2 and x equals 9. That's like saying 2 times 9 equals, find y when x equals 3. Y times 6. Okay, so I'm plugging into that inverse variation function. 2 times 9 gets me, I'm left with 18 equals 6y. What's y going to equal? Y equals 3. Okay. Now, what is my constant? In this function, my constant, remember, k equals y over x. So my constant is 18. Nice job, sir. And then step 3 says then graph. Now when I graph, I'm just going to sketch this. Okay. So when I graph, I'm going to sketch it. I have y equals 18 over x. I have y equals 18 over x. Again, taking this function right here, plugging in 18. Now I need some x values to choose. Which x values would I want to choose? 1, 2, 3, 4. Sound like great values, right? I could probably choose 5, 10. I mean, I could choose any value I want to here, right? Which x value could I not choose? 0, right? X cannot be 0. Understand that. X cannot be 0. So I would say x equals 1, 2, 3. I'm going to go 6 and 9. Why did I skip 4, 5, 7, 8?
So it can't be divided by 8.
Because it makes it easier, right? So what are my y values then? When I plug x values in, my y values are 18, 9, 6, 3, and 2. And I plot those coordinates. So 1, 18, 2, 9, 3, 6, 6, 3.
But where'd you get 18, 9, 6, 3, 2?
I plug those x values in, Jesse. And then 9, 2.
Oh, okay.
And I get a graph that looks something like that. Now, what other values do I need to pick then? I also need to pick the negative values. So I would choose x equals -1, -2, -3, -6, and -9. But what's that going to do to my y values? That's just going to make them negative. So I get -18, -9, -6, -3, and -2. And I plot those coordinates. -1, -18, -2, -9, -3, -6, -6, -3, and -9, -2. And I can sketch what my hyperbola would look like there. That's a hyperbola.
What's the point of the,
Not a parabola, a hyperbola.
what's the point of finding 3?
What's it?
What's the point of finding 3?
Finding 3?
First step, what's the point of doing that?
Because you got to find the other part of the inverse variant function. They just ask you to find it. Just 3 steps. Okay. All right. Take a couple seconds. Try number 7 and 8. A on both of them just asks you to find the constant. B just state is it direct or inverse. C and D ask you to actually plug values in and see what you're going to get back out. All right. So for C and D, using the functions they give you, plug those values in. Take a couple seconds. Try these. So number 1, the constant is 5. Is that direct or inverse variation? That is direct. Letter C. If y equals 10, what is x? So if you plug 10 in for y, what does x value have to be? 2. Letter D. If x equals 7, what is y? Y has to be 35. That's all it's asking there. Let's go to number 8. What is the constant of variation for the equation y equals 2 over x? K equals 2. Is this direct or inverse variation? This one would now be inverse variation. Letter C. Ooh, C was the tough one. If y equals 4, what is x? Does anybody think that? Yes, sir. 0.5. Yep. Because it's direct variation. It's not a whole fraction, really.
My eyeballs hurt.
Okay. And then letter D. If x equals 1, what is y? Y is then 2.
Do you guys have Coach Base?
No.
Why not?
So there you go.
We'll see that.
Direct and inverse variation here. Determine whether each graph represents a direct variation or an indirect variation. Number 9.
Direct.
Number 9, that'd be direct.
I mean inverse.
Indirect. Indirect really means inverse. Number 9 would be inverse variation.
Duh.
Okay, because it does make a hyperbola. Number 10 and 11. What would both of those be, would you say? Direct. They are direct because they form a line.
Can I shoot?
No.
I don't know, can you?
Do we get the third assignment?
There is your assignment.